In this video, we're going to be going over a concept called complementary events. And to do that, we're going to be using a simple example. And for our example, we're just going to have an experiment where we're rolling a single die, where the outcome can be 1, 2, 3, 4, 5, or 6. And we're going to write that out in our Venn diagram. So we have our Venn diagram here, our rectangle, with our different sample points in our sample space. And then we have two different events. We have event A, where if we roll a 1, 2, or 3, we're satisfying event A. Then we're going to have event B, where if we roll a 3 or a 6, we're satisfying event B. So event A is this green circle inside our Venn diagram, and event B is this blue circle inside of our Venn diagram. So to talk about a complementary event, we say that an event is complementary if we have A, and then we say A complement is just a new event. That means that A doesn't happen. So that means we run the experiment and we get an outcome, but that outcome does not satisfy A. So if we look at what A means, we have A is 1, 2, or 3, and our total possible outcomes are 1, 2, 3, 4, 5, and 6, which means that our A complement is the event happening of not 1, 2, or 3, which means we only have 4, 5, and 6 as possibilities. So we're going to call this a complementary event of A, and we can do the same thing for B. So if we wanted to write B complement, we would just do B with a little c. We say that is B complement, which means it is equal to the complement of B. So that means B doesn't happen. So we have 1, 2, we can't use 3, and then we have 4, 5, and then not 6. So we have two examples here of complementary events. So basically a complementary event means that the given original event does not happen. So A complement means A doesn't happen, and B complement means B doesn't happen. Now there's one rule associated with complementary events, and that is if we look at the probability of A, so we say the probability of A happening plus the probability of A complement, that sum, the total probability there, is always equal to 1. Now if you look at our Venn diagram, that should be a little bit intuitive. So we see if our Venn diagram, we have an event 1, 2, or 3, which is event A. And if event A doesn't happen, that's everything outside of that circle, then we just have 4, 5, and 6, which is all the remaining data points. So for any complementary event, if we have the probability of that event plus the probability of its complement added together, that will always sum to 1.